All right, Catapult project. So the first 3 steps of this are the same whether you're doing version A or version B. So hopefully you got your data collected. You should have 4 launch heights, height, reach, launch. With those 4, add them together like it shows up here, and then divide by 4, and that will get you that final box right there. Do the same thing with the distances. Take all 4 of them, add them together, divide by 4, and that will get you your average distance. We're going to use those 2 numbers to fill in these 3 points down here. So the first point, the vertex, that's our high point of the projectile path. So the height is going to be exactly the same. Up and down is controlled by your y coordinate. So we could just take that box and we're going to just plug it in right there. The distance, however, is not the full distance. The projectile is only going to reach its peak point halfway through the flight path. So we'll go ahead and take this this box right here, and we're going to cut that in half. So take that, divide it by 2, and then half of that average distance we can plug in for the other part of the vertex. The x-intercept, that is going to be where the projectile lands. So the distance is going to be the full distance. That's our x coordinate. Our y coordinate is going to be when it hits the ground. So your y coordinate is already filled in for you at 0. And then the y-intercept, that is where x equals 0. So the distance is nothing. That we haven't shot that out of the catapult yet. So the projectile is not sitting on the ground. That's why it says 1 or 2 right here. You'll just kind of imagine how far above the ground your projectile is when it's sitting in the catapult, and that will be your y coordinate of your y-intercept. So with those 3 points identified, we can start plugging in those points to come up with our equations. If you're doing the version A, you'll notice it says vertex form, and it gives you a little bit different equation right here. That equation has almost no numbers in it, and so we want to plug in values first for h and k, and then for x and y, so that eventually we'll be able to find the a value. The a is that number at the very beginning of our equation, right after the equal sign. If we can find that a value, we'll know the slope of our graph. And so our instructions have us plugging in our h value first, and so we're just going to take the x coordinate of our vertex, plug it in for h, and so then it'll look like this. We can take also our y coordinate of our vertex, plug it in for k, and so that number ends up over here. That's why this is called vertex form, because we're using the vertex to create this equation. We also still have those x's and y's, so we'll need to take one more point. If we have the vertex and one more point, those points are enough to make the parabola exactly where we want it to be. So let's see here, we're going to use the x-intercept, and that's what it says over here. Substitute and the x and y coordinates of the x-intercept. And so, of course, x comes first. And so 81 is what we plug in where we see the x. So in place of x here, we put 81. And then in this case, the y is 0. Y is 0, and so we go over here, we see y, and instead we plug in 0. So at this point, we should have nothing, no letters except for the a's. Once you've plugged in the coordinates of both of those points, then the only thing we should have left to solve for is a. So the remaining steps talk about isolating that a, so we know, and again, that the a stands for our slope. So we've got a few steps to do this in. It looks like the first thing that we can do is actually what's inside the parentheses. Those are like terms, they're both numbers. So these two guys, 81 minus 40.5 turns into 40.5. So we have done what was inside the parentheses. Order of operations tells us to do exponents next. And so the next thing we do is square that number inside there. Of course, you'll have a number that is not the 40.5. You'll have your own number. But whatever that number is inside the parentheses, when you did the subtraction, you're going to square it, multiply it times itself. And that's the only thing that we changed going down to the next version of the equation. So in this version of the equation, you'll notice the a has two numbers next to it. It's being multiplied by something, and something is being added to it. And so this is the part where we start doing opposite operations, so we can get that a by itself. This is just a two-step equation, and the first step we took was to get rid of the number furthest away from the a. So whatever number you have being added to a, of course, take it away and it cancels. Make sure to add it to the other side as well, so that you have minus it, take it away from the other side as well, so that you end up with a negative number on the other side of the equal sign. Now we only have a being multiplied by a number, so we use the opposite of multiplication, and we go ahead and draw that division bar under that whole side. Might as well draw it underneath the whole side of the other side as well. And then we divide both sides by exactly what a is being multiplied. Anything divided by itself gives us 1. 1 times a is just a, and so therefore we get the a by itself. And whatever you get when you divide these two things, it should be a negative divided by a positive, so it'll definitely be a negative number. And it should be a pretty small number also. And then you'll know what your a value is. So the very last part of writing this in vertex form is taking that new a value, and we can use our original equation like this, and actually the one where we plugged in the h and k values would be the best one to use. So we're going to take this equation and plug it in down here. You'll see we have the x-coordinate of the vertex, which is our h value. We have the k-coordinate of the vertex, which is the y-coordinate of our vertex, which is our k value. And then the one thing that we just figured out was that a value. In place of a, we're going to put the number that we just found, and we're going to keep our x's and y's as variables. And now we have it in vertex form. So this equation, you're going to go ahead and start with it on the back side of the sheet. So you copy that to the top, and that's what we've got here. And now we're going to put this into standard form. This is what we've been practicing during our daily questions for about a week now. And so the very first thing that we notice is we have the exponent of 2 up here, and we're going to write that in expanded form. So basically, whatever you have inside your parentheses, just put another copy of it right next to itself. And that'll allow us to do the multiplication that we need to do. So just killed my program. All right, I think there's probably going to be a part 2 to this after I figure it out.